inverse functions. To be specific, we're talking about trig inverse functions. So let's go ahead and review our basic functions in trig. So y is equal to sine of x. Okay, y is equal to cosine of x. And y is equal to tangent of x. And we're going to find inverse of each one of these. So to find inverse, you know we're going to switch x and y. And you're going to get sine of y. And this becomes x is equal to cosine of y. And this becomes x is equal to tangent of y. Well, we can't write it like this. So what we're going to do is we're going to take inverse of both sides. So the inverse will look like this. Sine inverse of x is equal to sine inverse of sine of y. Okay, and inverse and sine, they undo each other. So you're going to get y is equal to sine inverse of x. So this is the inverse of sine function. We're going to do the same thing here. You're going to take cosine inverse of both sides. So cosine inverse of a cosine of y. And these undo each other. So you're going to get y is equal to cosine inverse of x. And then we're going to do the same thing with the tangent. We're going to take a tan inverse of both sides. And of course on the right side, tan inverse and tangent will undo each other. So you're going to get y is equal to tan inverse of x. Okay, so sometimes when you write in some books, sine inverse can be written also as the arc sine of x. And of course cosine inverse can be written as arc cosine of x, and you'll see why in a little bit. And tangent inverse, instead of writing this, it's not negative 1 power, so it's an inverse, so you can also write this as a arc tangent of x, so you won't be confused with the negative 1 power. So these are all inverse. These are the 3 trig functions we need to work on. The other 3 we don't have to worry about. We can manipulate that by using these 3. Okay. So let's look at the graph. It'll make more sense. Okay. If you remember y is equal to sine of x, the graph of that will look like this. Okay. And of course, the highest value is going to be 1, the lowest value is going to be negative 1, and that's 0 to 2 pi. Okay, and then obviously over here it's going to go to negative 2 pi. Okay, here's the problem. If you were to, this is my y and that's my x-axis. If you were to switch x and y axis, okay, this curve now looks like this. Okay, it will look like that, and of course when that happens we don't have an inverse function. Okay, so we don't have an inverse function, so that's my x and that's my y. And of course we also know that x and y switch, so when you have 1 on the top and negative 1 on the bottom, this is going to be negative 1 to the left and then 1 to the right, and of course now all the way over here is 2 pi, and on the bottom it's going to be negative 2 pi. But this is not a function because it fails a vertical line test. So we can't use this. So we're stuck. How do we come up with an inverse function? So if you notice real close, okay, from here, which is where I have pi, negative pi over 2, to here, where that value is positive pi over 2, if I just look at this curve, that's a positive value, and this is a negative value. All of this just repeats all over again. So we don't need to worry about everything else. And if you can just look at this part from there, and then erase the rest of the sine curve, okay? And then when we flip it, okay, and y is equal to x. So we're going to flip this. When we're talking about inverse, remember we're going to flip it on the 45-degree angle line right there. So we're going to fold on that, we're going to flip it. So when you flip it on that line, y is equal to x, the inverse of y is equal to sine inverse of x will look like this. We'll start here. It's going to be cupped down, and it's going to be cut up, almost like a tangent. The only thing is it stops. It doesn't. You can't put arrows at the end. Okay? And it doesn't have any vertical asymptote. So this is now, remember, x and y switch. So I have to switch those. So it's not y. So it's going to. This is going to be -1, and that's going to be 1, and this is going to be pi over 2, and it's going to be negative pi over 2. So we do have to state the domain and the range. The domain is from here to here. I'll state that in interval notation. So domain is -1 to 1. And then the range, we have the y values, and it goes from negative pi halves to pi halves. So the range is negative pi halves to pi halves. Okay, that is the graph of a sine inverse. Okay. Without going through a lot of explanation on cosine inverse, I'll just state what cosine inverse graph looks like. Okay, so it works on the same principle that I did with the sine. So the cosine inverse graph, you have to limit that graph also, just like we did the sine. So the cosine inverse graph will be cup up and then cup down. Okay, and then the high point here is going to be pi. That's my y-axis. And then the low point is going to be 0. And obviously it's going to be -1, and that's going to be +1. Okay. So in the middle it's going to be pi over 2. This is the cosine inverse. So I got to state the domain and the range. Domain is the distance from here to here. Those are my x values. So I'll state an interval notation, -1 to 1. And then the range is going to go from 0 to pi. So 0 to pi. And it's the domain and range of the cosine inverse. Of course, we also have one more to do, which is the tan inverse. So let's take care of that. So if you were to switch x and y's and tan inverse, the inverse graph will look like this. Remember, tan function has vertical asymptote, but this one has horizontal asymptote. Okay. And that's going to be at pi over 2. And then you got another one here, and it's going to be negative pi over 2, and you're going to have minus. The tan inverse will look like this, cup up, and then it's going to be cup down. But tan inverse does go on forever. This is y is equal to tan inverse of x. Okay, what is the domain and the range? Domain, it goes from here to all the way from left all the way to the right, so it goes all the way across. So that means it's all real. And then the range goes from negative pi halves to pi halves. But I have to put parentheses because I'm not including those two values. So because the vertical, because the horizontal asymptote. So negative pi halves to pi halves. And that's the domain and the range. And you have to know both domain and range, okay, to be able to answer the questions. Okay. Alright. Now what does this mean? So let's go back. What does this mean from unit circle? And this is the hard part. So y is equal to sine inverse of x. You know what the graph of that looks like since you have this memorized. Okay, cup up, cup down, looks like a tangent curve. Pi over 2 to negative pi over 2. And then from -1 to 1. Okay. X-axis, y-axis. Okay, this is the sine inverse. Okay. Sine inverse goes from negative pi over 2 to pi over 2. On the unit circle, remember unit circle went 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Well, this is from this to pi over 2. Now, if I want to go to negative pi over 2, I have to go down So it goes in that direction. So sine inverse exists in the first and the fourth quadrant. Okay? Sine inverse exists only in the first and the fourth quadrant. It doesn't exist anywhere else because of that graph right there. You have to remember that. Okay? What about cosine inverse? Cosine inverse of x. Let's take a look at the graph of that again. Okay, graph looks like this. Okay, and that is going from pi to 0, either 1 to 1. So that means cosine inverse goes from 0 to pi. So if you look at the unit circle, there's my 0, there's my pi. So cosine inverse only exists in the first quadrant and the second quadrant. Of course, first quadrant is where it's going to be positive. Okay. Cosine values are positive, and second quadrant cosine values are negative. Same as sine inverse. Cosine values on quadrant 1 are positive, and then the sine values will be negative in quadrant 4. Okay, so we have to look at one more, and then take a look at the unit circle on that. Tangent inverse of x. Okay, we know what tangent inverse looks like. It's going to be cut up and cut down. It's got arrows on both ends. It's got a horizontal asymptote at pi over 2. And it's got another one on the bottom. And that's also at pi over 2. Okay, so that means cosine inverse, or tan inverse, goes from negative pi over 2 to pi over 2. Well, where is that on the unit circle? There's 0, there's pi over 2, and here's my negative pi over 2. So I can't include that because I got an asymptote, so it goes to here, but it doesn't actually reach pi over 2, and it goes down, and it doesn't reach negative pi over 2. So my domain here, remember, that is negative pi over 2 with simplitude and pi over 2. That was actually my range for tan inverse. Okay. Alright. So let's figure out what this all means. This is like a Jeopardy question. So if someone came up and asked you what is sine of pi over 6, you would say 1/2. But what if someone came up and asked you sine inverse of 1/2? Then you have to say pi over 6. So now we're trying to find the angle. We already know the side, the ratio of the sides, we need to find the angle. What if I say, what is cosine inverse of rad 2 over 2? Well, then you would say that's pi over 4. Okay, and what if I say, what is sine inverse of pi over 3? Oh, no, don't say that. Okay. So what if I say sine of pi over 3? Okay, sine of pi over 3, obviously it's going to be rad 3 over 2. Okay, then we have to say what is sine inverse of rad 3 over 2? Well, that would be pi over 3. Okay, so now, what about tan inverse of 1? Well, that's going to be pi over 4, because that's the only place where a tangent, because tangent of pi fourths is 1. So we're going backwards, okay, and you got to be careful, okay. So let's do some tricky examples. So here's an example 1. All right, well, let's start with the easy one and go tricky. Okay, let's go with sine inverse of sine of pi over 6. Simplify that. Well, of course, we're going to work on the inside out. So sine of pi 6 is 1/2. So sine inverse of 1/2. Of course, inverse of sine inverse of 1/2 is going to be pi 6. So then going back to the angle. Okay, that's easy. Okay, what about cosine? Okay, inverse of a cosine of pi over 3. Well, first let's find that. What is cosine of pi over 3? Well, cosine of pi over 3 is 1/2. Okay, so 1/2. Okay? And then what is cosine inverse of 1/2? That's going to be pi over 3. So about this time, you've kind of figured out, well, they undo each other, and then they're going to disappear. Okay? Well, that's tangent of pi over 4. So we know now what is tangent of pi over 4. So tangent of pi over 4 is really 1. And what is tan inverse of 1? Tangent 1 is pi over 4. Okay, so they keep undoing each other, but not always. So let's do some tricky examples where that doesn't happen. Okay, so let's say we have sine inverse of sine of 5 pi over 6. Okay, what is sine of 5 pi over 6? Let's go take it to unit circle. Okay, 5 pi 6 is there. That's my 5 pi 6. And that's my sine. So that's going to be 1/2. Okay, so this turns into 1/2. Sine inverse of 1/2. Alright, sine inverse only exists in the first and the second quadrant. First quadrant is positive, second quadrant is negative. So we're looking at this where that is 1/2. But where does that occur? That doesn't occur at 5 pi 6, that occurs at pi 6. So, since tan inverse exists only in the first and the fourth, you have to go back and use first and the fourth quadrant to find the inverse of a function for sine. Okay, so that means my answer is pi 6. So my true answer is pi 6. So they don't always. Let's go find cosine of pi 4. Okay, cosine of pi 4. So pi 4 is over here. Okay, and that's my 5 pi 4. And cosine is that value, which is going to give me negative rad 2 over 2. Okay, so I have a cosine inverse of negative rad 2 over 2. Well, when I go cosine inverse, I can't use this quadrant. I have to only use the first and the second. And since that's negative, I have to use the second quadrant. I got to find that angle. And that angle is taken as a 3 pi over 4. So cosine inverse of that, negative rad 2 over 2 is going to be 3 pi over 4, not 5 pi 4. So this turns out to be 3 pi over 4. So if you notice, they did not undo each other, okay, because cosine inverse only exists in the first and the fourth. Let's do one for a tangent, okay. So let's say I have a tan inverse of, let's say, tangent of negative 1. Alright, now let's go 3 pi over 4. Okay, let's go find tangent of 3 pi over 4. Let's go look at the quadrant. Okay, this 3 pi force is going to be there. Okay, and 45 degree angle. Okay, this is going to be negative rad 2 over 2, and it's going to be rad 2 over 2. So tangent turns out to be negative 1. So I have a tan inverse of negative 1. Well, tan inverse does not exist in this quadrant, so I can't write 3 pi force. Tan inverse is negative, and the tan inverse only exists in the first and the fourth, and it's positive here, and it's negative there, so therefore I have to use this end, which I also have to go down, and that'll be negative pi over 4. So the answer of this is negative pi over 4. And this is negative pi over 4. Okay. Alright, so they don't always undo each other. Now, there's one more thing that we need to talk about. And let's say they give us something that's not part of the unit circle. Let's say they want us to find sine of tan inverse Okay. Okay, let's say it is tan inverse of 4/3. Okay, 4/3 is not part of the unit circle. So what they're really telling you is, they're telling you have a triangle, and that's what the 4/3 is. So you have some right triangle, okay? And this angle, we'll call that x. So this is the opposite side, and this is your adjacent side. So this is the opposite, which is 4, and that is the adjacent. Okay, so in a right triangle, if you know these two sides, you can find third side by using a Pythagorean theorem. Okay, so that means 3 squared plus 4 squared is equal to c squared. Is 9 plus 16 is equal to c squared. And that'll be 25 is equal to c squared. And then c is equal to plus or minus 5. The hypotenuse is always positive, so you have to use positive sign. Of course, if you know anything about geometry, you have a 3, 4, 5 right triangle. Okay, once you do that, because it's not part of the unit circle, okay, whenever it's not part of the unit circle, you have to create a right triangle to work this out. Then all you're doing is reading off what the sign is. Well, sign is opposite, okay, over hypotenuse. Okay, so that means this turns into 4/1. And that's your final answer. Alright, so that's it.